Oh, let's take a look at the question that you were saying. Question 6, chapter 3. Okay, here's 6. Which one did you choose? Did you get a haircut?
Yeah.
Do you remember question 6? Which one did you choose?
No, I just don't know how to do it.
Oh, okay, let's see then. Your vector is this, and B is this. What angle does A and B? Are you familiar with this I minus 2j or like a 4i minus 5j? Do you know what they're
Not
talking
really.
about? Oh. But you understand, last time you said you understand like triangle law, you understand, right?
Yeah. So it's just like I never like systematically learned vectors, but I did some problems and I basically know what it is, right?
Yeah, from common sense, a lot of vectors can be done. Yeah. So you understand like a vector law, right? Like the triangle law, you understand, right?
Yeah.
But the thing is, triangle law is a little bit difficult, right?
Mm-hmm.
You can't really, it's a little difficult to describe, right?
Mm-hmm.
So that's why not only we have triangle law, we also developed something that we already we actually learned that a little bit by projectile. Do you remember projectile?
Mm-hmm.
In projectile, we basically divide the initial velocity into two kinds of velocity, right?
Yeah.
One is horizontal and the other one is vertical, right? This is the same thing. This, I divide all vector into xy coordinates. Does that make sense? Horizontal component and vertical component. Does that make sense? Which means I plus 2j in this xy system. Can you tell me what's I plus 2j? Can you find? So of course, horizontal means I. This is 2i. This is j, and this is 2j. Does that make sense? Can you find I negative 2j?
Negative 2.
Yeah, negative
This is
2j. That's
I.
positive.
Then it's gonna be
Negative
like
2j. Yeah.
this like here.
Yes. So this is the one that represents vector A. So in the same sphere, I can also have 4i minus 5j, right?
Mm-hmm.
Instead of using the traditional like triangle law, I can add them horizontally and add them vertically, and then use triangle law. Does that make sense? Which means I can add 4i plus 4i together. This is like terms, right? And then negative 2j plus negative 5j, which is 5i plus negative 7j, right?
Mm-hmm.
I can say that when you add that, which means this is going to be their vector adding. Does that make sense?
Yeah.
Which means I add them horizontally and then add them vertically and then combine them. So it's making a little sense, right?
Yeah.
If you don't believe that, you can, really draw it. That also works. Yeah. For example, can you draw 4 and 4i minus 5j? 4i minus 5j. Draw B.
Basically like that.
Yeah. And then if I add this two, do you know like a parallelogram law? Are you familiar with parallelogram law?
Like
平行四边形法则. Are you familiar with that? Yes, that. So in order to add this A plus B, I can just, make, well, it's a little difficult to make it, right? But you know what I'm talking about. I'm going to draw a little, like a parallelogram, right? And making this one as my vector, right? So if I do that, you find that this one, can you find that parallelogram for this two?
it's like
This two make a parallelogram. It's a little difficult though.
yeah.
Let me make it. No, you want to do it? Yes, so you can imagine this thing in between is gonna be my adding of a and b, right?
Yeah.
Which is just the one that I said, 5i and negative 7j. See? Does that make sense?
Yeah.
Which means I add them by parts, then I add them. That still works, right?
Yeah.
So that's why I can just find, adding 5i plus 7j. Can you draw 5i in a new one? Let's draw in a new one. Make it kind of clear. Making in this 5i minus 7j. Can you draw it? So this is adding, right? This is the result, a plus b. Yeah, like that. Yes. So he's asking this one, right? The angle, what angle you have with x-axis, right?
Yeah.
He's asking. So can you find this angle? If this is 5, this is 5i, this is negative 7j. Use trigonometry? Because ABCD
Isn't
is
this
trigonometry.
like the polar coordinates?
Which one?
Polar coordinate.
Can you mark it?
Oh, never mind. Oh, this
Okay.
is 7. So
Yeah, this is 7. This is theta.
yeah, so like tan theta
Yeah.
equals to uh 7 over 5. So
Yes.
theta equals to arctan. Oh,
Yeah.
so
Which is gonna be b, right?
yeah.
Yeah. Is it making sense?
Yeah.
So number 6, what should we remember about number 6?
Uh, we should draw it and then use trigonometry.
Yes. And also we should remember triangle law or parallelogram law, and also remember adding it horizontally, right? Adding it vertically, right?
Mm-hmm.
I can basically just like term, right?
Yeah.
If it's a like term, just add it, and then you can. In this way, I don't have to draw it, right? Because from algebra, I just know, right?
Mm-hmm.
That 5i minus 7j is kind of easy, right? When you add it that way, it's a little bit easier. Next one, let's see. That's 6, and then question 1 you don't have problem, right? And question 2, B, C you have problem, right? Let's see question 2. The question 2. Nth problem? Is this the one? Question
Yeah.
2? Question 1 is, can you draw the picture? Yeah, 22 north, and 30 east, and 14 north east. Yes. So how far has it traveled from its original position? How far does it travel is basically talking about, wait, it's distance or it's displacement.
I don't know how to calculate these two. I don't know how to calculate like multiple. I never learned it.
How far has it traveled from its original position? You think it's a displacement or you think it's a distance? I have to make sure about that first.
Distance.
So distance, I need this, right? And I need this, and I need that, right?
Yeah.
Isn't that the distance?
Oh, no, I mean the displacement.
Oh, you think it's a displacement? How far has the traveled from its origin? Yes, if
Yeah.
it's a displacement, that's another case. So if it's a displacement, yeah, what you asked is making sense. In this part is okay, right?
Yeah.
Can you find this part?
I don't know. I don't.
Okay, I can divide it. So first, this is like the divide and conquer thing. I can divide it. You see, this part is
Yeah, I only know this is 20, and then I don't know what this part is.
this is 30, right? This is 20. All I need is this part, right? And this part, right?
Yeah.
So let me get that little triangle here. It's a northeast, so it's a 45-degree, right?
Yeah.
So this is 45, and this is 14. Can you find this by trigonometry?
But if it's just 45, then we don't really need trigonometry. It's just like this thing. Wait, I'm pretty sure if it's x root 2 equals to 14, right?
Yeah. It's basically 7 times square root 2 over 2, which is 7 square root 2, which is around 10, I think. So 7 times 1.4.4 is around 10. So let's say this is 7 square root 2, and there's also 7 square root 2, right?
Okay, we can use trigonometry still then. Yeah.
Yeah. Does that make sense? So I
Yeah.
can find that, right? I think we can use, can you find 7 square root 2 is what? I think it's around a little 10, probably.
Calculate it.
You can ask ChatGPT or like
Let's do 1.4 times 7.
around 10, right?
9.8. That's
Okay, so let's say 10. Let's say 10. 9.8, right? So let's say 10. And because it's kind of easy. So this is 40 then, right? Because 30 plus 10 is 40. And this is 20 plus 10 is 30, right?
Yeah.
Does that make sense? So I can find the how far, right? This
Yeah,
displacement.
the answer has a much difficult thing. I don't know what.
The answer sheet is much difficult.
Yeah.
He's using trigonometry, right?
I'm not sure.
Let me see the answer. Oh, he is using the component adding thing, which we don't have to,
But
which
like
is the same thing.
a free response is like it's not only just one answer, right?
Yeah, you have to give the process. Yeah, you have to give the process, and you don't really have to as long you draw it right. You don't have to do it that way because he like when we get 10-10, it's the same thing. Actually, they also get 10-10 from like what's that? From trigonometry, they also get 10-10, right?
Okay.
And we can just draw it as this one is, 20 plus 10, and this is 30 plus 10. That's good enough. And you can use just the trigonometry. Oh, use Pythagoras this time, right? It's just a displacement, like a dot x, like a displacement maybe. It just equals to 30 square and 40 square, right?
Yep.
He's using adding of the vectors with component, with x component, y component. It's just the one that we did like question 6. C, if an aunt, B is okay, right?
Yeah.
You didn't know how to use trigonometry to get this? How do I feel that you can know this?
Yeah, I know now.
Maybe you didn't find it before. If an ant does not want to travel further than 80 centimeters from its original position, how much further north could it walk?
So for
Do you
this
know it
one,
now?
like we have the east is like 40, right? So can we just like do like since it does not want to travel 80 meters, then it's this thing is gonna be x. So 80.
Yeah, exactly.
And then calculate x and then minus it from 30 now.
Yes. It's Pythagoras, right? 80 squared minus 40 squared, right? And the square root that, right?
Yeah.
And wait, that's the how far is this? And they also talk about, how much further north could it? You should
this part minus this 30.
Yeah, minus 30. Yeah, that would be the final result. Yes, that's good. Let's see what's next. And 3 is okay. And 4 is okay. Right, then this is chapter 4. Question 1, you have problem, right? Let's see question 4.
Because like I don't know, I never had an AP test before. I
Yeah.
thought like free response question you have to like basically match exactly how the answer does it.
Oh, what do you mean? You mean multiple choice is confusing you?
No, for free response.
Oh, for response? Yeah, sometimes you have to describe it.
No, I mean
We're-
like exactly how the answer does.
Oh, oh, how exactly should we write that end problem? Well, let me write the end problem. Well,
Like for
first,
example, everything has to be like answer.
well, so far you can just give them as many details as you can. It won't take much, right? Oh, I think your microphone is off. Jeff, your microphone somehow is off. So is that making sense? You can just get the process a little bit more details, and that'll be do the trick right now. Because they're asking for the process, just give a little more process. If you hesitate, just write more. And for the end problem, you basically have to draw this and then mark this theta 45. And you can find the thing. You can give it a name, saying it's D1, this is D2, and find D1 is 14 cosine 45 degree, and D2 is 14 sine 45 degree, and then get it around 10. And then what? And then D, doing a different picture about this, is writing this one is 30 plus 10, and this one is 20 plus 10. And that will do the trick, just using the Pythagoras. And describing a little word, that'd be nice too. Does that make sense? It's kind of like the word problem that we did in math. Let's do the question 1. You choose AC. Oh, let's see. C is acceleration is 0. Select 2 answers. Which of the following true concerning this motion? I can understand that the displacement is 0. Why you want to choose C? Acceleration is being 0. Do you think its acceleration is being 0? How do
I
you prove?
didn't learn like circular path before, and then now
Oh.
I learned it, and then I now know that like velocity has both direction and magnitude. And since going down a circle, the direction is always changing, so acceleration was always changing as well.
Yeah. So you can choose D, but not C, right?
Yeah.
Yeah, right.
I didn't learn circular motion.
Okay. We're gonna get circular motion in like later in one chapter. And well, we're gonna get more mathematical.
Like centripetal force, right?
Yeah, yeah. 3 and question 8. Question 8. Remember 8? Did you even choose for?
Like there's like a flight time formula and also like the range formula. I didn't know that.
Yeah. Do you remember now?
I read it. I wrote it down.
Do you still have it?
Yeah, it's like kind of weird though. It's like uh H. Right. I don't know. I forgot the time formula.
So well, anyway, let's see.
Oh yeah. Range. The range is like velocity v0 squared times sine 2 theta over g, and then height is like v0 sine theta, the entire thing squared over 2g.
kick with the initial 10 and calculate its total time.
I forgot what's the time formula.
Well, this one, we don't really have a specific time formula really in that matter. So let me draw it first. So that's a 30-degree angle. And then you kick with 10 to calculate its total time, assuming error is this. So it didn't say anything, so eventually we assume it dropped on the ground, right? Like this. That make sense? From vertical point of view, basically, this is the whole path. But from vertical point of view, isn't that just go, you know, to the top and then go back, right? This is the vertical point of view, right?
Yeah.
If that's the case, my initial velocity is just v0y, right? Does that make sense?
Yeah.
And
Wait,
my
what?
final,
Wait, hold on. What did you say?
like this is v0, and do I have a component, vertical component is v0y, right?
Yeah.
No. And then eventually it's negative v0y is my velocity, right? You gotta
Yeah.
change the direction, right? And so I can use my acceleration form, a equals to delta v over delta t, right? So delta t is going to be my delta v, which is final velocity minus initial velocity, which is negative v0y minus negative negative 0y, right? Does that make sense? So this is negative v0y, right?
Oh yeah.
So which is 2 negative, right? Negative 2 negative v0y, the component. And divided by the acceleration. What's the acceleration when you go upward and then downward vertically? What's the acceleration?
Upward is like negative 9.5 meter per second, and downward is 9.5.
I think it's all the same. Why? Because I assume the positive is up. And so the direction for g acceleration is always down, right? So I guess
Yeah.
it's always negative 10, right?
Yeah.
Or negative g. It's right, negative g. Does that make sense? So
Yeah.
the formula, if you want to write, is 2 negative g v0 y over negative g. And negative is gone. So basically it's 2v0y over g, right?
Yeah.
And v0y is what? What's the component vertical from the initial velocity? What's the v0y? This is v0. This is v0x, right? This is v0y, right? So what's the v0y? That's the 38 degree.
That's like sine
Yes.
30.
Sine 30 times 10, right?
Uh-huh.
Initial velocity 10 times sine 30. And time 2, which is 20.
Wait,
over.
what's the flight time formula again?
What's
2v0y over g.
Yes, this is the time. Of course, it only works in this form. In this path. You go up, you go down. Sometimes, especially when you shoot something like a cannon, they can go there. That's not this formula anymore, right?
Yeah.
Only when it's going up, going down like a symmetrical thing.
Okay.
So and so divided by g, which is 10, so it's just 2 times sine theta. So which is eventually is 1, right? Does that make sense?
Yeah.
So this is question 8. I have to say you have to know this and know this, right?
Yeah.
And well, if you remember this, that'd be nice too. That's 8. What's the next question? 8 and 10. Let's see 10. Which of the following statements is true concerning the motion of an ideal projectile launched at an angle of 45 degrees to horizontal, like this? You're choosing 10. Let me see which one you're choosing. 10, oh, you didn't choose. Let's take a look at A. see whether A is right. The acceleration vector. Can you read A?
The acceleration vector points opposite to the velocity vector on the way up, and the same direction as the velocity is on the way down. I'm pretty sure that is not right because like the acceleration vector points are like always down. Right?
Yeah, G acceleration always down. Yeah.
Yeah, so like the horizontal, there's no acceleration horizontally. It's just velocity always the same.
Yeah. So their acceleration basically is changing, right? So that's definitely not wrong, right? I mean, that's definitely wrong. Okay,
So
B. We don't have to go to
speed,
detail. Just go B.
no, there's always G.
There's always a component horizontally, right? Your vertical speed at the top is really 0, but you have horizontal one, which is left. C. The total speed
No,
remains constant. No, right? Because you have G acceleration.
the vertical speed. I don't think the vertical speed decreases. Does it?
The vertical
Oh,
speed.
it does.
It does, right? Because you have opponent component in here, but your G acceleration is getting you, right? It's decreasing you, right? And when you get the top, it starts to accelerate you down, right?
Yeah.
So D is right, right? Also, we don't really have a choice. A, B, C, we rule them all. 10. That's 10. Next one is 12, I guess. You mark 12. Let's see 12. Can I read 12? You remember 12?
Yeah.
Now we'll do 12 then. Yeah, how do you want to do 12? You still remember? You can read it if you don't remember.
I didn't know this. I thought if it was like double, then it would just quadruple. Because that was like basically how everything went.
Ah, yeah. Hey, that's the right answer. You guess it?
Yeah.
Oh, let me prove it. So because initially it's V0, right? And then eventually it's 0. So that's why you stop. And this is X. And you have acceleration. Remember this part, talking about acceleration, they don't really have time talking about this, right?
Oh.
So, and the second time is also with twice V0 here, 2V0, and also 0 in here. And this time, say we don't really know this. And how about the acceleration? Assuming the acceleration is constant, deceleration is constant, what would be the skidding distance of the same part? So we're traveling. Which means that acceleration should be the same too, right? To the same car, right? Which big five can you think about? Acceleration is the same. A is here, also A is here. No time concern. V initial.
The last one.
Yeah, 0 square minus V0 square equals to 2 AX, right? Sure.
But I'm back.
Alright. So now we have the equation 1, 0 minus v initial 0 square and 2ax, right?
Yeah.
Formula number 5. And the second situation is what? How do you get the second formula in second situation? Can you write the second equation?
Hold on a second. All right.
This is the second situation. This is the first situation. We already did it. Can you get the second situation formula? It is also big 5, number 5.
So it's gonna.
See? Initial velocity now is 2v0, right? Yes, 0
So it's gonna be
minus.
4v0.
Yeah,
yeah.
exactly.
I get it.
Yeah, that's why it's going to be 4x, right?
Yeah.
Because the a is the same. And also because the deceleration is constant, it tells us. This is 12. Let's see, next one. This is 12. And next one is question 1. This is the problem D. This is A, B. This is C, right? Question problem.
Yeah.
Let's see question C. You answer A, B, D, E, and your problem is with question C, right? Is this one?
Yeah.
So what's the displacement of the car? Do you have answer?
What?
You don't know how to find it, right?
Yeah.
From 0 to 7. Oh, this one we didn't really cover that much in the question that you asked me. Displacement is area. Have you heard that before?
No.
The displacement of the car. See this. Oh, let me just. Have you learned calculus yet? No.
Not yet.
So let's just see. I'm gonna prove if it's constant velocity. See, if it is a constant velocity, let's say from here to here is constant velocity. How do you find the displacement? You should use the time delta t time the v, right? Does that make sense?
Yeah.
If it is a constant velocity, is this area, right? V time delta t, right? Does that make sense? Can I say this rectangular area is gonna be my displacement formula? Can you imagine that all this is rectangular? Every line I draw is a rectangular area. Does that make sense? I just add them all together. Does that make sense?
Yeah.
So since V times T is going to be my area, right? So the area covered in here is going to be my displacement. Is that making sense? I need calculus to totally prove it, but hopefully you can get the sense.
Yeah.
Is that making sense?
Yeah.
All the you can imagine if I have to prove it a little. So I would just draw something like this. This is kind of like a tiny, teeny rectangular area. Does that make sense?
Yeah.
Does this make sense? If I say this is rectangular, do you? It's a little bit different. See that?
Yeah, that's like the integral thing, right?
Yeah, yeah. Did you learn integral?
Not yet. Only a little. I've learned derivatives and.
Oh, derivative and integral. Yes, that's good.
Yeah,
yes, that's the integral area thing, right? You accumulate a
sure
lot
that's
of.
like anti-derivative. There's like definite and indefinite, right?
Yeah, yeah. This is a definite. This is the definite integral. Very nice. Right, you recognize. So I basically add so many rectangular area, right? So that's why I can say area, because each one of them is a little area, right? For example, each one of them is a little tiny, distance, right? See, I add a lot of tiny distance, displacement, and I accumulate my displacement. I add a lot of tiny area, and I get my total area, right? So in this way, can I say that? Ooh, what's going on? In this way, I can say area is the displacement on some level. Does that make sense?
Yeah.
So basically, he asked me the displacement. So I guess it's just the area. Does that make sense? Can you find the area on the other hand?
Probably.
Well, in integral, you probably haven't learned this is one positive area. This is a negative area. You have to subtract that. Does that make sense to you?
Okay.
It's making sense because in here is all positive. You're going to the right? If right is the positive, and in here it's all down. You have to minus. So you go back, right?
Mm-hmm.
Okay. Can you find the two triangles area? Find the angle here. Find the triangle area here, and find the triangle area here. How to find the triangle? No, it's geometry problem.
Then it's like base times height divided by 2.
Yes. So what's the first one? This base is 5, right? So what's the base time height?
5 times 20.
Yeah, 5 times 20. 100. And you have time 1 or 2, right? Which is 50, right?
No.
And what's the second part? This small area is what?
2 times 10.
And you also time 1 over 2, right? Time 1 over 2, which is 20. Oh, wait, 2 times 10 is 20, and it's 10. So this is 50, this is 10. So what's the final result about displacement? Don't forget a time 1 over 2. So this is 50, this is a 10. So what's the final result of the displacement? Yes. Right. So in here, we should remember displacement is area, right? The integral area. Just be careful with the positive and negative. Good memory about the integral areas. It's also called antiderivative. Yes. Let's see, which is the next one. Question 2, C and D. Okay. Can you read C? See, you still remember it?
Yeah.
Can you read C? Do you still remember C? You're reading C?
Mm-hmm.
For what value of the... Wait, what's your range for the question B? Let me see it. Do you remember it?
No.
You just find us a V0 squared times sine 2 theta over G, right? That you remember, right? So that is VG squared, V0 squared times sine 2 theta over G, right? Is this the one for B?
Uh-huh.
And now he's asking when this is becoming the maximum, right?
Yeah.
V0 is constant number, right?
Yeah.
And he's talking about the entire thing is the maximum, which means sine 2 theta is maximum because G is constant again, right?
Yeah.
So sine 2 theta, when is the maximum? Sine 2 theta, when can you get a maximum value?
2 sine cosine.
Which means it's kind of sine theta, the maximum value is what?
1.
1, right? Sine 2 theta is also 1, right?
Yeah.
It's when you're being 1, what's your 2 theta's angle?
Pretty sure it's 90.
Yeah, so 2 theta is 90, so theta is what?
45.
45. Does that make sense? We actually did
Yeah.
it as one choosing question, kind of, probably. So is it making sense if I say 45 degrees is the answer C?
Yeah.
Okay. How about D? Let me see whether D is the problem. Oh, D is also the problem. Say D. What's your question for D? Can you read D? That's a little long. Can you read question D? Do you still remember question D? It's been a while. Do you still remember question D?
No.
You can read it. Compute the time. This one. That elapses between passing through the horizontal line and the height h in both directions, ascending or descending. That is computed time required for both projects to pass through the 2 points in this figure. They want you to know the time, right? What's so special about this 2 points? What's so special about this point and about this point? About this point?
I don't know.
What do you know about this point? Can you describe this point?
All I know is where it's like meets this line.
Yeah, to meet h basically, right? So
Yeah.
so which means the displacement dot y is h, right?
Yeah.
Does that make sense?
Uh,
Do you remember the dot y formula for projectile? I mean, do you remember it?
Yeah.
What's the formula for like a dot y for this
Delta
kind?
y. Delta y. Wait, no, hold on. That was delta x. I'm pretty sure it was like y equals y0 plus v0 t plus 1 over gt squared.
Yeah, so it's basically v0yt minus 1 over 2 gt squared, right?
Yeah.
What's your v0y? I think you can use question A, probably can also solve it.
Yeah.
Do you remember question A? You have an answer for question A, right? Let's just use that. Because you find that dot y is your question A, right? When you question A, you find an h, right? Let me see your question A answer. Oh, here, see? V0 sine theta square over 2g. Do you remember that? Do you remember the question A answer? This is you did it yourself, right? You're basically substituting everything. Does that make sense?
Yeah.
And this equals to v0 squared and sine theta squared over 2g. Can I consider you know this already? Because this is your question A, right?
Yeah.
I substitute everything, this is what I get. And now I say this one is what? It's h, is it? Does that make sense?
Okay.
This whole thing is h, right?
Yeah.
So this one is let me think about this. I probably shouldn't use it. Let's use yours. Don't use A. A is probably going to get us a little further. Let's use your plan. V0y times t minus 1 over 2 gt, gt squared. Can you get a formula about this? This v0, this is if this is velocity, this is v0y, right? Does that make sense?
Yeah.
So how do you get this? Equals to h, right?
Yeah.
Isn't it a quadratic equation? Does this look like a quadratic equation for you?
Kind of.
Yeah, right? T as a variable, right?
Yeah.
And v0y, is v0y something I know? I guess no. I have to substitute v0y eventually. Let's take a look at that. They say h is in here. Compute the time. See that 0. I guess I have to use it anyway. What's your v0y here? What's your v0y?
I don't really know.
Well, this is a v0. V0.
Yeah.
This is a theta 0, right?
Mm-hmm.
What's v0y then? This is v0y.
Then
Trigonometry?
it's the cosine. No, it's sine.
Sine, right? Sine. So this is v0. I guess I can use v0y to solve it. Otherwise, I have to do a little bit further. Let's use v0y for a second and see whether I can simplify this or not. And then eventually, if I can just introduce v0y as v0 times sine theta 0, right? So how do you solve? If you say this, did you say that you find this one as a little quadratic equation? So how do you solve this quadratic equation then?
Quadratic formula.
Oh, the big one, right?
Yeah.
So let's substitute then. Negative b plus and minus. You're familiar with this one, right?
Yeah.
So let's substitute. If you substitute this, which is it's a little difficult for substitution. Gotta be careful, don't make a mistake. Okay, substitution for this one. How do you substitute? I probably make this 1 over 2 gt squared and minus v0 yt and minus plus h. Does that make sense?
Yeah.
So how do I substitute this formula? Put this quadratic to solve. See, this is a, right? This is a. 1 over 2 g is a. This is basically b. This is c, right?
Yeah.
How do you substitute?
Negative v0y plus minus
Yeah.
the square root of v0y squared minus 4 times half of g times h over g.
Over 1 over g, which is g, right? Great. So now I have t for 2, right? Because I have a t1 in here, I have a t2 in here. Is that making sense?
Yeah.
So what's the final? They said the time, compute the time between this horizontal line in both directions. Which is t2 minus t1, basically, right?
Yeah.
We are getting t, so which means your plus must be t2, right? Your minus must be t1, right?
Yeah.
Too bad we don't have a direct formula. So how to find t1 minus t2? How to find t1 minus t2? Well, let's find t1, t2 first. What's t1? With this big equation, what's t1? You have 2t, right?
Oh.
What's t1? The first time you get the high h. What's t1? With this formula.
Yeah.
Which one is t1? You have plus and minus. You have to make a choice.
What?
Wait, t1. T1 is the first one. It's the smaller one. You should minus, right?
Oh.
Yeah, it's v0y minus that big thing over. Oh, I can simplify this because this is 2gh. 4 times 1 over 2 is 2gh. Okay, this is then v0y squared minus 2gh and over g, right? And t2, what's t2? That's the plus one, right?
Yeah.
I took the minus one as first one. The other one is definitely plus. And over g. So what's t2 minus t1 finally? Is the time in between?
Then it's just
v0y is gone, right? If you minus. Yeah. And what's left is only that square root thing, right?
That's 2 times.
Yeah, 2 of that. 2 times
Negative.
This v0 v. I think it's positive, right? It's positive minus that negative, so it's positive. Right? 2. Ooh, let me write it here. 2 square root v0y squared minus 2gh over g, right? That's the final result. Does that make sense?
Yeah.
This is the time. This is a pretty popular topic. They tested it several times. So you better, well, I think it's better to remember it. Does that make sense? So you have an h, you make a quadratic equation, and then you solve it. And then you find t1, and you find t2, and then you do t2 minus t1. Does that make sense?
Yeah.
If they tell you you get a trajectory, which is the height, and it'll have 2 time, and what is the time between this point, you basically find the time from here to here, right? Does that make sense?
Yeah.
Learn how to draw it, and yeah, use the quadratic equation, right?
Yeah.
And of course, you understand displacement. That's question 2. Let's see question 3. BC is the problem. BC. Wait, what's wrong? Oh.
We have class tomorrow, right?
Yeah.
So then, can we do? Let's do chapter 5 tomorrow. Can we do like the new?
Oh, you want to do the new one?
Yeah, let's do it now.
Okay. We finished this 3 chapters basically, and we go on with the energy now. Dynamics, we finished them all, right? And so it's time for energy. Oh, this is not my order, so they choose circular motion as the next one. Sure, let's use circular motion. Have you seen like your circular centripetal force? And this is centripetal acceleration.
Yeah, I'm pretty sure basically, like what I've known is like this is a circle, and it goes around here, and there's always a centripetal force here. That's the
Yeah.
only force that's acting on it.
Yes.
Goes like-
Yes.
And then there's also, I forgot what force it is, but there's another force when it's here. There's a force vertically, and it's the tangent to the circle.
Yeah. Yeah. That's the tangent line is the velocity of the direction of the velocity.
Yeah, that's the direction. Yeah.
So you remember this somehow you learned it before, right?
Yeah.
Acceleration v squared over r. Do you know that?
No. What's
Okay.
So acceleration is v squared over the radius. All right.
Yes. You haven't learned calculus that much, so I can't really use the normal way to prove this. Let's use data to check whether this one is right. I can actually find all the velocity, all the velocity of the circular motion. I think you mute yourself.
Yeah, I know.
No. So I find all the velocity, and I find all the radius, and then I find all the mass, and then I know my F equals to ma is still working, right?
Yeah.
So basically, I can calculate all the forces, right? I mean the sigma force. Does that make sense?
Yeah.
Use this way, I can find that. For example, if let's say m is 10, the force is 10, m is 2. So my acceleration must be 5, right? Does that make sense to you?
Yeah.
So my acceleration must be 10 over 2, which is 5, according to Newton's second law. But I can somehow find this is happening to my relation between v squared over r. Which means if this one velocity is 10 squared, let's say it's 10 squared, and then my r is, I measure is just 120. So this is 100 over 20, which is still 5, right? Does that make any sense? Does that make any sense to you?
Can you say that again?
So because I have problem if I don't use calculus, it's difficult to prove. And I can use all the data to collect and to see whether this formula is working. I find my velocity is 10, and my find radius is 20. So eventually I find this, I make a lot of different sets, And all this can prove that my v squared over r is always going to be equals to my f over m. Does that make sense?
Yeah.
So eventually I can say they must be equal, they equals to a, and this one must also equals to a, right? This is Newton's second law. And this, well, is basically, well, you find the acceleration always is equals to v squared over r. Does that make sense?
Yeah.
As long as it's a constant circular motion, that will happen. And which can be done, can be proved by calculus. You finish learning it. So now I can just find it every time you make a circular motion. This is working. Does that make sense?
Yeah.
So let's do problem 1 then. Example 1. Can you do example 1?
Yeah.
Let's do 1. How do we do 1? Yeah. Oh, you remember you have to keep some notes and then send it to the group, right?
Yeah.
Okay, you can just keep your record and something. Yes, which is 18, right? 36 divided by 2. So 18 is my acceleration, right? Then what's my net force? The next question, what's the net force? You know, response for this motion.
The net force responsible. That's like, that's just the gravitational force. Shit.
No.
Or is it like the centripetal force?
Yes, centripetal force is my net force.
But I don't know how to calculate that.
Yeah, centripetal force is gonna be my m time acceleration, centripetal acceleration, which gonna be my f centripetal force, which is also going to my sigma f. In this case, it's also going to my sigma f. Does that make sense?
All right. So now it's gonna be 6 squared over 2 times 5 equals to 18 times 5 equals 9.
Yeah, 19 Newton. Yeah, that's my centripetal force. And that's also my net force. Net force, in a lot of cases, is the centripetal force, but it's not always like that. We're going to have a feature like a pendulum, this kind of question, which, well, you have to say, if you really want to say this, some people ask me, is this a formula? This one is not a formula. You can't really find it in any textbook, well, as far as I know. It's because there are some special cases. You have to say your sigma f c, which means in the centripetal force, in the point to the center direction is gonna be fc. Does that make sense? Because there are some things which is perpendicular to that one doesn't really count. So you can't really find, this one is not a typical like a formula, although we use it a lot, but it's not always work. This is question 1. Here's 2. Figure 2.
Equation given to the, 10 kilogram mass is tension strain, that braking strain, you're gonna need maximum speed. Okay, so we got another one, which is acceleration centripetal equals to velocity squared. Oh wait, we don't have a velocity.
Yeah, he wanted you to find that velocity.
Then we're gonna F centripetal equals mass times AC. So it has 200 equals to 10 times AC. So AC equals 20. That's the max. So 20 equals to V squared over R. R is 80 centimeters.
Yeah.
0.8 meters. So
yeah. So what's the velocity or V maximum?
Wait, hold on. What is 20 times 8?
Yeah, 160, I guess.
16. Right?
Wait, 160. Oh, 160 divided by 10 is 16, right? Yeah.
16 equals to V squared. So V equals 4
Yeah, 4.
meters per second.
Yeah. So which
4 meters.
means what? I'm gonna open my camera. Which means if you go beyond 4, what will happen?
It's gonna break.
Yeah. So you can't really have too far. Same thing as you turned your car, right? If
Yeah.
your velocity is too high, you can't really get that turn, right?
Yeah.
That's why you slow down. If you don't, you can't. There's not enough providing for the centripetal force.
Yeah.
Example 3.
Wait, so is this still centripetal force? Like,
Yeah. It's still centripetal force, right? They'd ask you centripetal force.
so V squared is 25. So 25 divided by the radius 5. So AC equals to 5 meter per second squared.
Yeah.
And then the force acting on it is the 800 newtons times to 5. Wait.
Wait. You need the mass now, right? You need to use
Yeah,
M times. So where is your mass?
800 newtons.
Wait, that's not mass. Newton is force. That's weight. You need to calculate the mass.
That's divided by 10.
Yeah, 80 then, right?
Yeah,
80 times that 5.
400.
Yeah,
400 newtons.
So that answers
Okay,
the first question.
Yeah.
And then what provides what? Yeah, what is better? What provides the centripetal force?
Gravity?
See, there's a person running, right? He's turning around the curve, right?
Yeah.
So the gravity is in this direction. If he's standing in here, gravity is in here, and
Then,
he's
like,
balanced.
because is there like a vector thing? Because his velocity is going that way.
Yeah,
and then he's going the perpendicular.
Yeah. So who is providing that perpendicular force? Not gravity. Gravity is vertical, right?
Yeah, I know.
Yeah.
Is there other force?
Can you let me turn my camera. Can you do that thing on yourself? Let me do that thing on myself. See, you turn. See, almost nothing is giving you something to turn, right? But I'm turning, right?
Yeah.
Who is giving that? Friction. There's nothing else. Also because there's nothing
friction.
else. Yeah, friction. And you don't feel it is because you basically, when you turn, you basically don't move, right? Is that what you mean?
Yeah.
So, which means not only is friction, also there's also there is no other choice. Also because you don't move, so it's a static friction. Does that make sense?
Static friction.
Yes. It's basically you're there, you don't go, anywhere. You just turn, right?
Yeah.
So it's a static friction provides the centripetal force normally when you turn, or when car turns, or when bicycle turns, it's the static friction. Does that make sense?
Yeah.
If the next question, what would happen? What could happen if R were smaller?
So, like, for example, if radius was like 1, then the AC would be 25 meters per second. You could go faster. And then so therefore the centripetal force would be stronger.
Yeah. But your static friction, as we learned, is limited, right? You can't really the ground can't provide anything, right? That's why the racing car is dangerous sometimes, right? When you turn, when you want to save time, you want to turn, R is getting smaller, right? It's better, right? You think it's better, but you could lose control of the car, right? Because the friction is not enough. So I guess you have to be careful, right?
Yeah.
And eventually, this, if you get really small, this is what happens. Slip. You slip, basically, right?
Oh yeah.
This is the answer. You need this keyword. You slip because friction, static friction can't provide enough because it's limited. You have a maximum there. Question 4. This turning like a thing is also very popular. Question 4. Roller coaster.
It's 15 meters. Normal force.
Yeah.
By the way, that's just the gravitational force there.
Well, which normal force are you talking about? Oh, at this point.
I don't
There,
understand. How do we find the normal force if normal force is just basically the weight?
So let's draw this. They say it's a circular loop, right?
Yeah.
Forget about other part of the roller coaster. So this one is in here, right? Let's only talk about in here. And they're at the very top, right? Here is the roller coaster. Here's in the car, and the people upside down, right? So this is the people upside down. The acceleration is pointing downward in here, right?
Yeah.
And the diameter is 40, and the mass of the car, there's 40, there's a 15, and there's a 120. So in the car and the passengers, find a magnitude. The normal force, can you tell me what other forces are there on this car and this person altogether system? Gravity, right? What else is in here?
The centripetal force?
Well, centripetal force is not exactly a force. It's effect force. What's the actual force? Do you understand when I say effect force? Yes. The friction, I don't think they talk about it, so there's probably no friction. What other forces are there? And they already mentioned normal force. It must be a normal force, right? Find the magnitude of normal force exerted by the track on the car.
The car has a supporting force. Some shit. Something.
So this is gravity. There's also a normal force. Does that make any sense to you?
I don't know.
This is the thing. If you are like a facing upside down, right? This is the person, right?
Yeah.
But there must be something normal for exerted by the track. The track is here. He can only give a normal force in this direction, right? Does that make sense? You can't really ask the track to give you this direction force, right? It doesn't make any sense, right? Because the track is in here, right?
Yeah.
So the only right way to draw this is the normal force down, right? Is it making sense? This is a little difficult to view it. Because before, if it is in here, we say normal force in here, right?
Okay.
Now I also said your normal force coming from the track. And also think about this. Let me draw it in a better way. If in a simplified form, the track and the person is more like this. It's kind of like a bead. Do you know bead?
No.
This little ball, which there's a hole in there. Do you know that? There's a little bead. It's kind of like that. Does that mean it's making sense to you? Is it making sense?
Yeah.
Oh, where are you? I can't see you. Oh, you're invisible now? So here's the bead. Let me turn on my camera. See, this is kind of like the bead. This is the track. See, this is the track. This is the bead. Does that make sense? So the normal force, the bead is going to fall down, right? Does that make sense?
Yeah.
And the bead is not, well, technically it's not the bead. If I use the bead metaphor, it's probably a bad idea in here. Because in that, there is another question about the bead. In that case, the normal force is actually in the other direction. This one, the track is in here, so the only making sense force is in here, the normal force. Does that make sense? Does it make sense? Normal force, adding the gravity, two force together, which
So
provide my
normal
centripetal.
plus, that's basically 2 times the gravity.
Yeah, normal plus gravity, right?
Yeah. But doesn't normal force equal to gravity as well?
No, that's only when, because it's the Newton's first law. For example, in there, Newton's first law is the rest. So that's why you balance it back by, well, you press the ground and the ground pushes you back by a normal force. But that's not those, this is not that situation.
Okay.
Does that make sense?
Okay.
So you are tied up on the track, and now they give you a force. So F normal plus Fg equals to what? This equals to what? This is the sigma F, right?
Yeah.
This equals to what? According to Newton's second law.
F equals MA.
Yeah, Ma. A is
FA, like AF, AC.
yeah, AC, and which is
V squared over
yes, 15 squared over R, which is what? 1 over 2 times 40, which is 20, right?
Yeah.
So with this, I can find F normal, right? Because Fg is also just used, 120G, right?
Yeah.
This is making sense to you?
Yeah.
Okay, here's number 4. The rest of it is through in the calculation. And we can also calculate example 5 then, which is also the same question. They just talk about different situations. Can you read question 5? Oh, also, the last time is 1500 Newton for normal force. Can you read question 5?
The previous example, the net force of the car follows me straight down. Why does a car fall straight down? Because there's a supporting force. Like,
Yeah.
since it's like this, there's like force surrounding like this, right?
Yeah. Why doesn't it fall down?
Is a centripetal force as well.
No, not exactly. It's the same. It's the same like phenomenon, but you have to think about at that moment. What's your direction of the speed when you are here? The direction of your velocity is to the left, right?
Yeah.
But your acceleration is where? Is in which direction?
Down.
Downward, right? Velocity to the left and acceleration to the downward.
Yeah.
So what will happen next moment? Say they would just drop a little bit left as you draw it, right?
Yeah.
They draw. It just well, you can just say velocity will just kind of face down to the left, right? At the angle, right?
Yeah.
So that also makes sure it's going to a circular motion, right? Does that make sense?
Yeah.
And also, one of the things that I can prove normal force is in that direction is because your gravity is simply not enough to provide centripetal force. Does that make sense? If you
Yeah.
do this, for example, you find your gravity in here, your normal force have to be in this direction because otherwise it won't make a circular motion. Does that make sense? You simply, if your force is in your normal force in that direction, it's not even enough because you have to minus something, right?
Yeah.
If you don't minus something, the gravity is still not enough. So you need the normal force to help you to provide more centripetal force.
Yeah.
So this is example 5. Let's see. 6. Can I read 6? Same situation. All this happened and again and again. You got to be careful. Can I read 6? Example 6.
How the normal force in example 14? Oh yeah, that's just the normal force would be opposite direction of that.
Yeah. Now this time you have to be the opposite direction. Oh, let's take a look at this. I think this looks better. Oh, maybe that looks better already. Let me show you. See, this one also show that it's the normal forces in here, right? Because this is the car, right? And also, this is a roller coaster car. See that? It's a roller coaster car. So that's why the normal force, from common sense, is also downward. Does that make sense? Does this make sense to you? Is it? Here?
Yeah.
This one, right? The normal force that gives you must be downward, right? There's no other option, right?
Yeah.
And how about now? It's 6. How do you do 6 then? How can you find the number 6 normal force? Can you do number 6?
Yeah.
How to find number 6? This.
Is it? Never mind. I don't know.
So, well, the situation just changed into normal, right? Into downward, right? So the car looks in like that, right? Can you draw all the forces of the car this time? The forces at this moment on the car?
Yeah. Hold on. Where's my annotate? So there's first of all, there's the centripetal force.
Wait, not centripetal. Centripetal is the effect force. When we draw a force diagram, there's no centripetal force. All of them add together, it's a centripetal force.
Oh.
So what are the actual force? When I say actual force, it's an effect force, right? Yeah, normal force. It's a real force. It's an actual force.
And then there's a gravitational force.
Yes, gravity is still there. Oh, this one you have to be careful. Who is bigger?
Oh, I know.
Yeah, you have to be bigger, right? Normal force. Otherwise, you can't make circular motion anymore, right? No one provides centripetal acceleration. Yes. So can you find the sigma F in the central direction? So what's the sigma F in vertical direction? Yes. How would a normal force car if the car was at the bottom? So the velocity is still that for t, I think. Let me see it. Yeah. Oh, not 40. 15. Can you get in all the number to find the actual normal force? I'm sensing that one definitely have to be bigger this time. How to find normal force? One formula is sigma f is Fn minus Fg. Sigma f also equals to what? Yes, acceleration. You mean acceleration time m, right?
Oh yeah.
Hmm.
Yeah, that's how you go.
Oh, Fg plus then. Okay. Fn equals to Fg plus mv square over r. Is that what you meant?
Yeah.
Okay. Fg is 12000, right? Plus 1200 times 15 squared over 20, right? Does that make sense?
Yeah.
Let me see. Let me compare. Before, at the top is 1500, and now it's 25. That one is 1500 or 15. Oh, 1500. Oh, that one is comparatively a lot smaller, right? 1500 Newton. This one is 25500, right? 10 times more than that, right?
Yeah.
I guess if you want to make a roller coaster, you got to be careful with the force that provides in here, right?
Mhm.
You got to make it strong enough. Is this making sense?
Yeah.
Okay. And now let's go to, have you learned gravitational?
I'm
Well,
pretty sure that's like the one we need, right?
yeah. It's called universal gravitational constant or
It's like
universal gravitational
it's
force.
times the constant of gravity of the times the two masses, and
Yeah.
then divided by the square of the distance of their centers.
Yes, very nice. Although it's not called we just call gravitational constant, right? It's a little bit different number than the 9.8 thing.
It's like I'm pretty sure that's like 6.67 times like
Yeah,
10 to the
very
negative
nice.
11.
Yes. This is good. Yes, that's the G constant. Uh, Last time before we called G acceleration, which is 9.8
Yeah,
or 10. This
that's
time is
like Earth gravity.
yeah. This time is everywhere, right? This is one of the most mysterious things. Still, there's so many things about this we don't know. Well, we have to say there that smells God and theology is in there. Other than that, physics, so far a lot of science is working on this. So since you know this, let's do one question. Example 7.
Oh yeah. We have the formula, so it's like um because we got like the gravity goes to constant G m1 m2 over r squared. We got this thing, we put this in. So we're gonna turn the mass of the Earth to m2. So it's gonna
Yeah,
be gravity. So we got 10 times that thing. That I'll just say r squared
yeah,
divided by the universal constant times your mass.
yes, great. Let's see how big is that. That is a 6.1 times 10 to the 24th power. So that's somehow, I guess this is somehow we measured the Earth, right? We can't really
Yeah.
have a device to measure that is a little taking too much resources. In exploring the space and the universe and Earth is already kind of wasting a lot of money. I'm not saying it's bad because I like physics. Some of them is not
Like,
necessary.
can you like then you can't like measure the gravity mass of like black holes, right? That's like
Yeah, so you can, you can, but that's well, so far we didn't build one at least. Example 8.
gravity, absolute gravity.
Now this one is a little tricky.
What? Thank you. G equals yeah.
Hmm.
Is it something? Does it have to do like, for example, if someone's like here, works here, it's gonna be like this. But since like this Earth is like more of an ellipse than not just like not a complete circle. So this is gonna be closer. That's gonna be farther.
Well, that I don't know, but I do know is F normal. It's still, let's say this one. There's a F normal in here, right?
No.
Right? And then there would be, let's say, they say true weight.
Yeah.
Which means F0. This time we don't call gravity anymore. We call F0, which is mg0. Is that mean?
Yeah.
So if I move this in here, that'll be a, F normal in here minus mg 0, right?
Yeah.
Does that make sense? This is mg0. Oh, which one is greater, do you think?
Which one?
F normal and mg0, which one is greater?
I'm pretty sure it's mg.
Yeah, mg0 have to be greater, right? Because you gotta provide, we're talking about this point, you gotta provide a centripetal acceleration, right? To make a circular motion. The Earth is turning, right? Because the Earth is rotational, right? It's rotating all the time. So I guess I should draw something like this. So now it's mg0, right? And F normal is what? What's F normal?
mg0.
F normal here is the measured weight. Does that mean? Show that it is at equator, the measured weight. And the weight that a scale would measure is mg, is less. So this one is mg.
Yeah.
Does that make
So
sense?
yeah.
So mg0 minus mg. And then which gonna be my mv squared over r, right?
Yeah.
But I don't really have v, right? Sadly. Do I have v? I don't have v, right? But do you know that v equals to omega r?
I don't know what that is.
Omega is angular velocity. Have you heard that before? Angular velocity?
No.
Now, let me just write this. V equals to 2 pi r over t, the period, right?
Yeah.
See, 2 pi over t is what? It's just omega. It's just well, I have to say, oh, if you don't know that, I can just use velocity. I can use this one, m equals to 2 pi r over t, which is velocity, right?
Yeah.
Because, well, t is what? 24 hour, right? Because of the period. That square over r. Does that make sense?
Yeah.
I think in this big equation, everything is there. Does that make sense to you?
Yeah.
Because I know r, right?
Oh.
We can derive the expression g from the previous one here. Does that make sense? This is that g. This is not the normal g that we use.
Yeah.
So they want to know their difference, which is m, the common factor, and g0 minus g, right? Does that make sense? And then m can be simplified. This is 2 pi r over t squared and over r, right?
Yeah.
So eventually that'll be what? Can you find the final result? This, of course, t is the rotation of the Earth is 24 hours, right? As we know.
Yeah. Yeah.
So what's the final result? So 2 pi r, which is 4 pi square and r square, divided by an r, which is 2 pi r. 4 pi square and r, right? Does that make sense?
Yeah.
Divided by t square, which I can find them all, right?
Yeah.
And the radius of the r we can find from previous question. So this is all the things that we can find. And why is that? Let me just show you the result. Let's see. Here's the result. This is the last question. So the result is when I substitute everything, so this is the radius of the Earth, and this is the time. Of course, I have the time 60 and 60 or 3600, right? So eventually G0 minus G is 0.034. Does that make sense? Which is too close to call. Does that make sense? Does that make sense?
Yeah.
So that's why we ignore that. Does that make sense? The rotation doesn't really influence the G acceleration that much. Does this make sense, this question?
Yeah.
Okay. We'll pick up 8 a little bit next time. So how long do we have for homework? Jeff, how long do we have for homework?
Well, like we have tomorrow, so I don't think very long.
1
I think
hour, 2
tomorrow you
hours?
can give me a long homework.
Okay, sure.
All right.
So, well, finish all the questions we did in the example, and
Yeah.
also the example that we did in
All
the correcting the one that I have problem. And you can still do. I think the rest of them we probably can all do it.
All right.
Yeah, just do chapter 6, the example one. They have all the answers. Is that okay?
Yeah. Okay.
Okay. Have a
Bye-bye.
good day. God bless you. Bye.